So hello, assalamu alaikum. My name is Manan. Today we are going to discuss about the chemistry, and the topic is solutions, colloids, and suspension. So what are these things? What are the characteristics of these things? We'll discuss every single thing about that. So first of all, we need some of the solutions. First of all, we need a beaker like this in every sector of this. All right. Now what we have to do is we have to understand the characteristics of this. First of all, remember one thing, that when you talk about the solutions, it means a mixture. It means a mixtures of liquids and solids, or liquid and liquid, or gas or solid, something like this. All states of matter are involved with this. So we have right now three solutions. These all are solutions, you can say mixtures, and this is the true solid. This is colloids, and this is suspension. First of all, we'll talk about the transparency. Transparent. First of all, we'll talk about the grid. What we say size. All right. First, we will talk about the size. So if we talk about the size, so solution has got 1 nm. You can say less than 1 nm. All right, less than 1 nm. If we talk about the colloid, so from 1 nm to 1000 nm, it has a size. If we talk about the suspension, so it has a greater than 1000 nm. All right, so we have talked about the size. Now we have to talk about the transparency. Transparency, if we talk about in this solution, true solution, so what does it mean? There's a simple recognition for the true solution. When you see any solution invisible, for example, you can see through this, means a glass of water. If you take the glass of water in the glass of glass, made up of glass, so you can easily see through that. Otherwise you will not be able to see through that. So the particles are, transparent. You can not see that. For example, if I give you the example, for example, this is H2O, which is water, and this is solvent, by the way. Okay, this is solvent. If you know the concept of solvent, it's good. And this is solute. So this is the sugar. Oh, sorry, this is the salt. So what does it made? Salt plus water. So this is the example for the true solution. When you pour the water, when you take the water and pour some of the salt in it, so it will become the true solution. You can easily see in that. And the size, you should remember, one less than 1 nm, the size of the particles. If we talk about the colloids, so there's an example. For example, the solvent that we have is mayonnaise. For example, that we have mayonnaise, and we pour some of the solute, which is milk. All right. For example, this is the milk. So the example should be mayo plus milk. Now what does it mean? Will it be visible or will it not be? So for this, we use the term translucent. Translucent. We use the term translucent for this. All right, because it is barely visible, but some of them are visible in the kind of under microscope. All right, there's a very less amount of things that are visible to naked eye. But if you talk about the like microscope, so you can easily see that, but in a very high microscope. If we talk about the suspension, so suspension got what you can say, for example, water. All right, you have some water, it is solvent. Water is solvent, by the way. And you pour some of the air particles or dust. Okay, I write here air dust, and these are here air dust. So you will be able to see that the particles are visible, not the particles, but the what is the solution is visible. It is not be visible. It will be sorry, it will be visible, it will be not visible. You can clearly see it. You can clearly see inside this. But if we talk about the throughness, that can you see through that? So in both of the terms, in collides and suspension, you cannot see through of them, but in the true solution you can. If we now, the third term that we have is what we say, settle down, settlement, you can say settlement. Now, what does it mean? It doesn't mean that they will settle and they will make their house and everything. Settlement, it just means the particles. Like for example, for the example, in the tea, when you pour some of the, what we say, sugar in the tea, you some pour of the, it just mix up in the tea. But when you put sugar in that too much, so it just lay down and settle down. That what does it mean? In the true solution, it's not. It does, particles doesn't settle down, particle doesn't settle down, all right. In the true solution, remember this thing, particle does not settle down. If we talk about this, so it doesn't settle down by its own, but you can do by coagulation. Coagulation means um remove charge to make it neutral, to make its mass heavy. This is the simple definition of the coagulation. Let me write here, coagulation. Alright, this is the term. Now, if you talk about the settlement of suspension, so it is already settled down. All the particles just settle down right here. Alright. Now, the final term, maybe this is the final term, which is the Tyndall effect. Tyndall effect. Now this is a very important topic, a very important point. You have to remember this thing, that for example, that we have a torch here. Let me make the torch here. Now for example, this is a torch here, and I put this torch on true solution, all right, and here is the screen. So you will see that the particles, the light will through out of this and will show on the screen, will show on the screen. All right, you agree that I just told you that it is transparent, so you can see through that, means the light can pass through that as well. This was the true solution. All right, true solution. Now if we talk about the collides, so what does it mean? Here is the screen, and if you on the light, turn on the light and try to make it through like that, so it will not, it will just stop right here and try to disperse. All right, there was so not so many dispersion, but yeah, little bit dispersion will be there, because of the, what we say, because of the settlement. The particles are not settled by their own, and it is already translucent, and the size is also bigger. Like there's a big difference in the size of the solution and the colloids. For example, here is less than 1 nm, even not the 1 nm, and here is from 1 nm to 1000 nm, which is a very big size in the terms of chemistry. So that's why it doesn't, we doesn't can say, we don't can say that it will like show on the screen. But if we talk about the suspension, let's draw here suspension, and the suspension screens is here. If we threw the light from here, so it will just disperse, and even not even like, what we say, even greater dispersion than this one. So yeah, that's why we can say that this suspension has the higher amount of settlement down particles, higher amount of dispersion in it, higher amount of Tyndall effect in it, and it is already invisible, which is in the terms of chemistry we can say opaque, in the thing in which we cannot see. Even the light cannot pass from it. All right, if you have a glass and you pour some of the suspension solution, so you cannot like get the light reflection. That's the also the thing. So we use the opaque for suspension, translucent for colloids, and the transparency, or you can say transparent, for the solution. I hope it got you interested, and let me know you a few other topics as well. I'll meet you in the next video. Bye bye.